Okay, let me start the presentation. Here's our contents. First, we're gonna talk about example 2.6, and next, we are gonna deal with probability models. To solve the problem, first, we generate the 500 normally distributed random variable for x1 and x2. As you can see in the figure, x1 and x2 is normally distributed. And when x1 plus the x2, it becomes also normal random variable. You also can see the graph, which is normally distributed. And when take the exponential to the x1, it becomes log-normal random variable. And x1 squared plus x2 squared, it becomes chi-squared random variable with this graph. And when x1 squared plus x2 squared and take the root, it becomes Rayleigh random variable with the means of 1.2366 and standard deviation of 0.42. We briefly just talk about the combination of random variable of x1, x2, which is normal random variable. Now we are going to talk about failure model. An item transistor are exempt to get the data set. If transistor is classified as non-repairable items, we are only interested in studying on the transistor until the first failure occurs. We call it time to failure, and we select the three models to fit the data set: log-normal distribution, normal distribution, and Weibull distribution. And this table above is data set. In here, Ft, a large Ft means that probability that the transistor fail within the time interval from 0 to t. And large Rt stands for the probability that the transistor survive the time interval from 0 to t. And Lt is the number of transistors that survives within the time interval. And now, plotting the Ft and Rt. As you can see in a graph, in two graphs, as time goes by, the failure function goes up, and the reliability function goes down, and finally reach to the zero. Put in another way, all the transistors are finally failed to function. And here is histogram. X-axis is about t, time to failure, and y-axis stands for the number of transistors that fail within each time interval. Now we are gonna fit the data set to the distribution model. This is probability density functions of Weibull, normal, and log-normal distribution. In this case, the random variable x is equal to time, t. And this is cumulative density function, which is equal to large ft, the probability of that fails within the time interval. So all the distribution finally reach to the value of 1. From the fitted graph, we can calculate means and standard deviation, and also we can calculate parameters. The parameter is defined which maximize the log likelihood. In other words, the graph is fitted to maximize following the maximum likelihood estimation. The aim of maximum likelihood estimation is find the parameter which makes the observed data most likely. So, using this likelihood value, we can easily compare the distribution, which one is better to fit. First, one distribution is set as null model, and another is set as alternative model. And then calculate the D using this value, and also calculate the p-value. And when the p-value is smaller than 0.05, the null model is rejected, and we can say that the alternative model is better to fit. Following this logic and calculation, we can conclude that viable distribution is most well fitted to failure model, to the data set. This is this type. And when we look into viable distribution parameter, the shape parameter alpha is approximately 1. So, as setting the alpha equal 1, viable distribution becomes exponential distribution. As shown figure above, the distribution is well suited to the bathtub curve. In fact, in reliability analysis, the exponential distribution is commonly used to show the failure rate. So that's all about my presentation. If you have any question or comments.
Good morning, everyone. My name is Il Yong-no. I'll talk about the first mini biweekly project. Our team members are Jungon and Yunsuk and me. The contents are solving example 2.6 and identifying distributions. First is solving example 2.6. If x1 and x2 are normally distributed with mean is equal to 0 and standard deviation is equal to 1, x1 plus x2 is normally distribution with mean is equal to 0 and variance equal to 2. Substitute this value in this formula, then we can obtain probability density function. Probability density function. PDF and histogram figure are like this. Next is finding exponential x1. Because x1 follows the normal distribution, exponential x1 is going to follow the log normal distribution. Substitute mean and standard deviation of x1 in this general log normal PDF, then we can obtain PDF like this. And these figures show PDF and histogram of exponential x1. Next is finding x1 square plus x2 square. if Z1, Z2, and Zk are independent and standard normal random variables, summation of Zi square is following chi-square distribution with k degree of freedom. So x1 square plus x2 square is following chi-square distribution with 2 degree of freedom. And then we can obtain probability density function like this. These figures show PDF and histogram of x1 square plus x2 square. Next is finding root to x1 square plus x2 square. If x1 and x2 are independent normal distribution, so this root to x1 square plus x2 square is following Rayleigh distribution. And then you can find the PDF like this. This figure shows the PDF and histogram of root to x1 square plus x2 square. Now that we have covered solving example 2.6, let's move on to identifying distribution. We have selected 3 probability models: log normal distribution, normal distribution, and variable distribution. We selected data set in failure time data for a specific compressor at the Norwegian process plant. All compressor failure in the time period from 1968 until 1989 have been recorded. In this period, a total of 321 failures occur. Among these failures, 19 critical failures and 231 non-critical failures occur. A critical failure is defined to be a failure causing compressor downtime. Non-critical failure may be corrected without having to close down the compressor. This is critical failure times in chronological order. In order to finding distribution of the data set, we have used the method for estimating cumulative distribution functions, and they have been evaluated by KS test. We can estimate CDF through the following method: mean rank method and median rank method. We can use the following probability distribution, which are better fit to the data sets: normal distribution, log normal distribution, and variable distribution. First of all, we can find the CDF of normal distribution using mean rank method. This figure shows when assume the data set follows normal distribution, then we can obtain the slope and intercept through this value. We can obtain parameter of CDF, and then we can find the cumulative distribution function. In order to obtain CDF about the log normal distribution and variable distribution, repeat these steps and find the parameter. And then the result is like this. This dot is data set, and the blue line is normal, and green line is log normal cumulative CDF, and red line is variable. As a result from this graph, conclusion is the data set follows the normal distribution, and this is median rank method is repeat the previous steps. So this is the result. Also, the data set follows the normal distribution. Yeah, thank you.
Hello everyone, my name is Kyuan Lee. I am today presenter about our bi-weekly mini project. Actually, the two teams already talking about the example 2.6, so I just quickly skip about the result. And I just briefly explain about the simple theory in here. And the last one is the 6 probability models are discussed in our lecture. Actually, there are so many probability models, but we choose the log normal distribution and normal distribution, exponential and wide distribution. At first, we choose actually the three things, log normal, normal, and exponential. But at the last time, at the final, when we finished the project, but at that time we suddenly noticed that exponential model is just existing for, especially for the failure model. So we additionally choose the while model too also. And then I'll briefly explain about our data set and talking about our result. The first one is example 2.6. This is our result. Actually, methodology is very powerful tools because we can easily generate this is the function of the norm RND. It means is normal random variable. So this RN generating 10,000 random variable values. So today I really especially thanks to the island because through actually before we didn't know about like this function and the defeat tools. It is very powerful. So maybe another thing is also using the defeat tools in here. So anyway, using the norm RND, we can generate in the normal random variable using with the 10,000 values, and then we plot the histogram like this. This is very simple theory, linear theorem. When linear theorem is actually very useful and very simple because when you want to analyze something unknown things, but we know the some linear variable and another linear variable together when we summation the one thing and another things, we can generate another linear random variable data. It is also random variable data. So we can easily notice that this is also, the shape is looks like the very shape. So this is normal random variable. The second thing is exponential. Oh, maybe the version is not same. So some errors in here. So histogram is like this. There is some comments a lot. Some of its application about the exponential, the measure of size of living tissues, especially for the biological application, and the distribution of city size, and the models of time to repair or failure maintainable system. This is the chi-square distribution. There is also some errors, but please understand me. And also the histogram and the PDF, the PDF is the graph looks like this. And this is some of its application is this PDF can be applied in inferential statistics and especially in chi-square test and to estimate the variance. The last one is the sorry, I'm really sorry about it. So really random variable shape is looks like this, and its sum of its application is also the layer PDF can be observed when analyzing the magnitude of a vector such as wind speed and the random complex number, whose real and the imaginary components are independent. This is very special comment, especially for the random variable. The next one is I explain about the 6 probability models I'll discuss in our lecture. I already mentioned that we choose the 4 probability model. The paper is talking about the reliability of actual loaded-driven pi groups. Actually, this pi groups is especially using for civil engineering, so you guys maybe couldn't understand about, so I briefly explain about the pi group. When we construction the building, this is building, underground, I mean the basement, there is some, they have to construct the file at first, but the 1 or 2 pile is not enough because today's the building tool is very high, so we need another pile. When we put the file under the basement, there is the negative frictional. This is a negative frictional force. Due to this force, this building can't standing exactly above the ground. But this one file has some effective radius, and this file is also have effective radius. So when we construct those many files like this, it can consist of very sustainable ground basement. This is the group file, especially for in civil engineering. But so this paper is concerning about the cohesive and the cohesionless ground, and then number of case, and the spacing diameter means the diameter of this part. And the interesting is the fiber efficiency per number of its occurrence, the 2, 6, 8, 5, 6, 1. And this is the efficiency about the group files. So we analyze it using this probability model. Yes, this is the result. We selected 2 data. This data from the paper. So at first, in here, maybe you guys see this is the normal distribution, and this is low normal, and this is exponential model. Actually, the normal and the low normal distribution model looks like a quite fit as Giggle, but the exponential is totally different than our histogram data. So we need another model because we have to compare which one is properly to our database. So we additionally analyze the wild model. You guys already know there is 2 parameters, alpha and beta. So at first we fix the alpha parameter, the 0.9, and then we change the beta parameter like this, 1, 2.5, 2.5, 4, like this way. And then maybe you can see that when the fixed value alpha is 0.9, when the beta has the 7, the viable probability model looks like a quite fit as 50 here. So in the next one is also when we've set fix the beta value 7, and then we change the alpha value also, and then we can find out there is some very, very good parameter. Maybe it is the 0.09, how can I say 0.9, right? So we can have a conclusion. The alpha is 0.9, and with the beta is 7. That is the best model, especially for the wider probability model. And then we can compare the normal and the log normal and the wider distribution probability model like this. So in here, but actually it really looks like quite similar. So which one is the best one for our data set? So we need some criterion. This is the result. Actually, there is so many ways to compare or the making conclusion which the probability distribution model is the best one. The first one is chi-square test, and the second one is very difficult name in here. I just say KS test, and the Anderson-Darwin test, and using log likelihood method. Actually, I already mentioned about the DP2 in MATLAB. It is by powerful tool. When we analyzing the tool database, we can get the data, especially for the log likelihood value. In the MATLAB data, this is a log likelihood value actually, and then when we see that the log normal, and the exponential and variable, the normal has the largest value among the other things, like this and like this. So we can have a conclusion. Our data set for our data set, the normal distribution probability model is the best one. Okay, and we finally discuss about the parameters which characterize the model. Mean group efficiency, variance, and skewness in kurtosis. At the first presentation, I already mentioned talking about the kurtosis and skewness value. When the data is maybe the normal distribution model, the skewness has to close to the 0, and the kurtosis is close to the value has maybe 3, I remember like that. But there is some errors between the kurtosis and skewness actually, because we make a conclusion the normal distribution is the best one, but the skewness and the kurtosis has some errors in here, because I'm not sure why this phenomenon happened, because we couldn't understand it totally about the MATLAB processing, so maybe we have to consider or the studying about it. And the final conclusion is data set 2 has a bigger variance than one set, data set 1, and every data set has positive skewness. It means the graph looks like this maybe, and the data set 2 is more peak than data set 1. Yeah, this is our final conclusion. Yeah, thank you for.
Hello, hello. My name is Kim Kyung-seok, and the other team member is Ho Yong-hyun. Let me start the presentation of mini biweekly project. The contents consist of 5 parts. First, I will show you selected probability models and data set, and then fit selected probability models to data set, and we will evaluate probability models on how they fit the data set, and then we will discuss the parameters which characterize the model. First, select probability models. There are many kinds of probability models we learned in the class. The first one is log-normal distribution. The function of it is like this, but is some trouble. And it has 2 parameters which are mu and sigma. In the graph, there are many kinds of shape depending on the parameters. And the shape could change. Second one is gamma distribution. The function of it is like this. In the graph, it also has many kinds of shape depending on the parameters. Alpha is related to kurtosis, and beta is related to skewness. The third one is Rayleigh probability model. The function of it is like that, and it also has parameter which is sigma. Depending on the changing of parameter, there are many kinds of shape of function. Next, select data set. This table is hourly significant wave height. The random variable x is hourly significant wave height. As we know, the height of ocean wave always change. But there are some regular frequencies, and researchers surveying this data, checked it every hour, and got this data set. Observation post is Gyeongyalbi Island, and period of survey is from January to August last year. The number of data is about 4,000. This data set is from Korea Hydrographic and Oceanographic Administration. This graph is PDF of data set. X-axis is significant wave height, and Y-axis is probability of random variable X. As you see in the graph, skewness is positive and maybe kurtosis is a little high. So we could know that log normal distribution and gamma distribution or Weibull distribution model is proper for this data set. Next, fit selected probability models to data set. In log normal distribution, in the graph, there are graph of log normal distribution, and blue one is our data set. Yellow one, where mu is 0 and sigma is 1, is similar with our data set. Next, gamma distribution. In the graph, there are gamma distribution functions and our data set. The red one where alpha is 3 and beta is 1 is similar with our data set in terms of the shape. The next is Rayleigh probability function. In this case, the pink one where sigma is 1 is similar with our data set, blue line. Next, we will evaluate probability models on how they fit the data set. In the log normal distribution, when mu is equal to 0.1 and sigma is equal to 0.9, the shape of log normal distribution is corresponding to our data set like this. And in gamma distribution, when alpha is equal to 2 and beta is equal to 2, the model is corresponding to our PDF of data set. In the Rayleigh probability function, when sigma is equal to 1, the model is corresponding to our data set. Last, I will talk about discuss. I will talk about the parameters which characterize the model. In log normal distribution, when mu y is fixed, as sigma y increases, skewness tends to be positive and mode is getting closer to the y-axis, like this. in the gamma distribution, when beta is fixed, as alpha decreases, kurtosis tends to be positive and mode is getting closer to the y-axis. When alpha is fixed, is equal to when beta is fixed. Last, in the Rayleigh model, as sigma increases, kurtosis tends to be negative and mode tends to increase, like this. Thank you for your attention. Do you have any question?
Okay, a couple of comments I want to do. As I look at the 4 group presentation, it is really beyond my expectation. You really did well. And you speak English really well. And when you go out for broad study for, another degree, vice versa, I feel you shouldn't have any problem, but you have to practice hearing part is kind of part. You can't learn in a year. It takes time, but you have nothing to worry. I think you have really quality in the technical aspect in your talk. I feel I taught, that's what I expected. I just taught ABC. Then you can just extend out to, not up to Z yet, but at least D, E, F, G, H, I, J, K, vice versa. That's what beauty for crisis students. I don't want to see it, just ABC. Anybody can do it, but extend out. That's the beauty, and that's what really satisfaction all the faculty member wants to have, and that's what I see. Let's say send me your file for the project. For this project, please send me a file, just a copy of your file, and send it to e-bills. I want to really keep that there. And I, of course, didn't see in each group how you really produce the result. I expect all the member has a contribution, right? Yes or no? One guy just did it. Okay, you just don't have to worry, I did. That's not it. So you need a discussion on that. That is in a meaningful object. And I saw from video the equation builder is not working correctly. Are you using the mostly 100 or the word? What are you using? Word. 100. HWP. The equation builder. Because I see concepts presentation, equation builder didn't work properly. Lots of practice bricks all. So I'm going to find out why it happened. In your computer it may work, right? And suddenly when you take it, then go out in front of 100 different people, then you present it, all the garbage is a problem. So usually whenever I go to conference, I carry my own notebook. And as a backup, PDF file. PDF never works. So find out he really didn't resolve anything like that. So that's a little bit annoying. Ilion, not just accusing your presentation, no, you should never accuse anyone. Really, I don't know. There's no such a thing as class. When you present it, everybody has to see clearly, right? So the equation is too small, then people cannot see it. And it defeats some degree of emphasis. Make sure it's large, not huge, large enough, and everybody can really appreciate it. Yeshua or other people saying that units are important, especially x-axis. Of course, wave height for us to really open practices, data. So when really wonderful day. Okay, so this concludes Friday morning class time, and we'll continue from next Monday. The lectures. So, okay.